question, but there's easy traps that people fall into. So first trap, right? Anyone who's interested or anyone who might be interested is not your audience, right? So that's way too broad. You can't try to make a figure that's for everyone, right? And you shouldn't try to do that. So really what you want to think about is, who is going to be making a decision based off the figure that you're looking at, right? And you want to target that decision maker, right? So other people who are interested may still look at it and may still get insight from this thing, but you really want to focus the message of your figure on the person making the decision. Okay. Another trap to avoid is to sort of assume that your audience is like you, right? So things that convince you will not necessarily convince your audience. Things that are clear to you, or like language that you may use that's like clear to you, may not be clear to your audience. So you really have to think about who you're talking to. So what you have to do is anticipate that people are going to be skeptical, especially a lot of my experiences from publishing in like academic journals or research papers, right? So you can imagine like reviewers of the paper, right? These are people who are trying to reject your work. They're trying to find the flaws with it and poke holes in what you're doing, right? So that's not always the case, right? But if you're trying to convince somebody that the thing that you're doing is right, there's going to be some natural resistance because people believe whatever they're going to believe, right? So don't try to hide from those, right? You want to address those. The other thing is, before you even start making your figure, like I said, we're iterating on this analysis portion. You have to decide, what it is that you want your figure to convey when you make it. Like when a person sees your figure, what should they be thinking? Okay. So again, traps to avoid. Our goal is not to show all the data, right? The goal is to sort of to make the interpretation of that data easy, right? So again, we're thinking about the conclusion, like what was the result that we gleaned, and making sure that that's what's visible in the figure. But on those lines, right, we don't want to omit data that's potentially contradictory to our message because we don't like that data, right? It's like, oh, these are outliers that sort of make my whatever thing I just created not as good. Like I'll just won't show them. Like, right? People, especially discerning audiences, are going to very quickly realize that you've left stuff out, right? If you think about like an academic journal, people reviewing your papers are likely working in the area that you're doing research in. And if you don't cite their work, it's like, they're going to know it. And, or if you're saying like, oh, I have a new great search engine, and you don't mention Google as a competitor, like, it doesn't take long before people realize that. And if you lose credibility in your audience, like they're just gone, right? Like you're done. So when I say, be specific with the data that you're choosing to show, you need to show the data that's relevant to making your point. You don't want to hide things that obscure it, but if you have extra data that's irrelevant to the message, that you don't need to convey. Okay, first principle. So those are the sort of two parts of the process, right? You're going to start by asking two questions, right? What does your message say, and who's your audience? First principle here. Remove clutter. So clutter is anything that's going to take up space or ink on the page and doesn't convey or doesn't increase the understanding that you get from the image, right? And I put here in parentheses enough because a lot of things add some understanding, but maybe it's not actually that useful. So basically you have to think about, you want to be deliberate with everything that you're putting into your figure, right? So everything in there should have a purpose. So in the book, they give sort of 6 steps, which removes just about all the clutter. So I'll share those steps now with an example, and I'll have some caveats. The thing I'll say at the beginning is, your use case is specific. So when I say do this, you should really think, does that really apply to what I'm doing? And anyway. So here's the steps. So step number 1 is remove background shading and grid lines. And I know that's popular. There's a lot of frameworks that sort of put those in by default. I know a lot of people are fans of like Seaborn for a Python plotting library, kind of does this by default. Those are not needed. Okay. So you can just remove them. It's very easy. Borders also not needed. And so there's a principle. So in the book, they talk about the Gestalt principles of visual perception. And one of those principles is closure. And so basically, like if you have like an X and Y axis here, like I have on the right, your mind just draws the rest of the box without needing those bars. So they're really not serving a purpose. On this slide, it's even more prominent because the background is not quite white. So you can sort of see the white background on the plot in it. So that's slightly cheating, but anyway. Remove the border, that's not needed, okay. Data markers. So this is one that they're very adamant in the book that you don't want lines and markers. Okay, and I put an asterisk here because, well, one of the figures that we'll iterate on later will actually have, I deliberately choose to leave the line and a marker there. But the idea is like the line emphasizes the trend or the sort of the continuity of what you're doing. The points and emphasize the individual data points. So you decide which one is more important to you. Like, is the thing that you're looking at, a scattering of data that you've collected, or is it really the sort of the continuity and you convey the thing that's important?
As an undergrad, I worked under a guy who was had pretty strong opinions that people draw lines way too often.
So that was Abe for people on the line.
Hey, Travis.
Yeah. So
do you mind just saying what he said again, because it's hard to hear?
Oh, sorry. Yeah. So Abe just said that when he was in grad school.
So when I was an undergrad, I worked under a professor who had very strong opinions that people draw lines through their data way too often. And so for something like this, where, well, it's fake data, but maybe it's not so clear that at 25 it's halfway between the value at 20 and 30.
Yeah.
So to avoid doing that, on the other hand, with this one, that might make this plot hard to read if you only have the markers.
Yeah. Yeah. So when you connect it, you're sort of assuming, or you're sort of asserting that there's some continuity there, and in some cases that makes sense. In some cases it doesn't. You have to be careful. Okay. Step 4. So you're cleaning up the axes and the labels. So here I don't actually make any change. Oops. Back. That's mostly because I didn't have anything really on my labels already. But the point is that, again, you want to be deliberate, right? Do y-axes start from 0? Should they start from 0? Like, how many tick marks do I want to have on there? What sort of ranges do I want? If I have text labels for if say my x-axis were dates, and so I had text strings, you really don't want to have vertically oriented text or angled oriented. It's really hard to read, and so it just adds cognitive load. And maybe those specific dates aren't super important. So you sort of think about if the date is important, then maybe you're only going to show the ones that are most important, or maybe you're going to shorten how you represent those so you can put them more, right? So these are lots of things that can go into there. The point is that it should be deliberate and careful about that. So this is a principle that I know. Okay, I don't see Michaela on the phone here, but she'll have strong opinions that I'm wrong on this. So I was hoping we were going to get into a bit of a philosophical argument. But anyway, the recommendation is to label your data directly. And so getting rid of a legend and putting labels right on there. There's sort of 2 advantages to doing this that they call out in the book. One of them is that it adds load to sort of transfer from the legend over to the data. And you may think, well, that's not that hard to do. But when you look at the one on the right, it's definitely easier, right? Because the label's right there. Also, the legend kind of draws attention to the legend, which is not really the point, right? You want people to sort of be focusing on the data. The other sort of bonus side effect is, if you were to print this figure and say it printed in black and white, right? Are red and blue distinguishable when printed in black and white? Maybe they are, right? And you could be careful to try to make sure that those are distinguished in black and white. But when I've labeled them directly, it's already fixed, right? You can tell.
I mean, so this plot, and if it's in black and white, when the lines cross, how do I know which is which?
Yeah, there's that too.
It's a good point. Yeah.
I also think okay, with 2 lines, maybe that works better. If you have 10,
yeah,
then it's going to be.
So that's part of the when possible, and we'll see some examples of that. So Abe was pointing out that yeah, if you had more than 2 lines, or if they're like very close together, it's going to be really hard to label those individually. I 100% agree with that, and we'll see that. Somebody else on the line had a question. I don't know if that was
Tracy.
Tracy.
I don't know if you've come across it, but would be interested in your recommendations if it's not a line graph, but like a bar chart. Is there a similar recommendation for not having a legend, and how would that be enacted?
Yeah, so we'll see an example of that towards the end. So yes, you can also do that with bar charts. Yeah, and there's several ways you could do it. We'll see at least one at the end.
Perfect.
Scatter ones, it gets a little bit trickier, especially if you have a lot of scatter points on there. We'll see an example of that also. It does get trickier, but yeah, good questions. And then the final thing that you can do, and I don't personally know that this would be considered clutter. In the book, they call it clutter, but they say to leverage consistent colors. And so the way that they do that in their example is something like this, right? And personally, this is one where it's like, definitely be consistent with your coloring, right? Whether or not it's needed in this point, I don't know. So it can be debatable, but this is one of the things that they recommend in the book. And we'll see some examples following this that I think it does actually improve it. So, okay, so that's removing clutter. Yeah.
I think step 4 is that for labels, clean up the axes.
Mm-hmm.
Kind of surprised there's no labels for those axes on there.
Yeah, so I probably should have created some labels for those axes. That was a so.
What did they recommend for that?
So being clear,
Okay.
and what we're about to get into. So the next step, actually, which I'll just mention, the principle number 2 is to focus on the data. And so one of the things that they talk about in the book is not emphasizing, like you have labels on your axes, but the emphasis is not the labels. So like, you don't need like giant black bold let axis labels, because that sort of is drawing your attention to the label, and you really want to focus your attention on the data. So we'll see some examples of what to do with the legend and in the next couple of figures. Okay. So okay, so principle 2 is focus attention on the data, and in the book they talk about a bunch of pre-attentive attributes, and basically these are ways that subconsciously draw your attention to something, and you should strategically use these pre-attentive attributes to focus attention. So I'll illustrate some of these. So if you see this block of text, I ask you a question, say like how many 3s are in there, right? You've probably seen stuff like this on Facebook, right? So how many 3s are in there? You sort of look at it, count, right? Takes you maybe 5 seconds, I don't know, right? If I use a pre-attentive attribute, it's like, milliseconds. You can count those, right? So, intensity in this case is one of these pre-attentive attributes, and when you strategically use that, it makes whatever you're sort of pointing at easy to focus on, right? Here's some examples of other pre-attentive attributes. As you just sort of glance at those, you immediately see, like in each sort of grouping, something that's standing out, and your eye goes to the thing that's standing out, and that's because of those things are some of these pre-attentive attributes. And there's more in the book if you want to look through those, feel free. Anyway, so we'll leverage these with our data to sort of get people to focus their attention on the data, right, on the important message. One word of caution, right? You can't focus on everything, right? Definition of focus sort of means you can't do that, right? And so if you start putting pre-attentive attributes on everything, then people's attention, they don't know where to go. And so what that might look like, if you try to like color everything, like here's our number example, right? I've given each number a different color. If I say, okay, well, where are the 5s? Well, you sort of like glance around and like, okay, 5s are orange. And now I try to like mentally like only look for orange, like it's just hard, right? So you have to be careful to make sure that you are selective about what you want to focus on. The other thing I'll mention, like these pre-attentive attributes, like especially with these numbers, right? You can sort of unethically use these as well, right? Like if you think about like the Facebook posts, you might see this if I highlight 6 of the 3s, but I didn't highlight the 7th one, right? Then it's like, oh, well, I'm sort of being deceptive in the way that I'm making the figure, and it's maybe not wrong. Like when you look at it, it's like, oh, the numbers are still there, but it's really sort of being leveraged in a bad way. Right?
Yeah, you're accurate that there are 7 3s, but you're not being forthcoming and intentional.
Yeah, you're yeah. It's sort of like being, a magician at a show, right? Like you're using the sort of people's attention to focus on what you want them to focus on, and so okay, let's see. We saw those. So I'm going to talk about just the plan is to look at a couple of papers. So the first one is this global filter networks for image classification paper, and I'm not actually going to get into the details of the paper. Though what they're doing is they're proposing a new neural network architecture that they claim is better than using transformers for image classification. And if none of those words mean anything to you, it doesn't matter. Just keep in mind that global filter networks is their thing, and they're claiming it's better than the other things. Right? That's all you really need to know, right? And so I thumbed through the paper. This is published in NeurIPS. Their preprint is available in the archive. I think the proceedings from the conference itself just went live. But anyway, so I just thumbed through the paper, look at the figures and say what's there, and can we make these better? Right? So here's one page. This is just a screen capture from one of the pages in the article. You can see some figures there. They're not too bad, right? I mean, as far as figures go, if you've looked through many journal papers, you'll know that there's some really bad figures out there. And on the scale of really bad, these aren't really bad. Okay, but I think there's things we can do to improve them. So we're going to go through both of these. So like the top row, figure 2, and then the bottom, figure 3, and see if we can improve those. So the first one, and I'll just mention here, so this is the original from the paper. They didn't provide the data to recreate this figure, so I sort of recreated my own in Spirit. And so we're going to iterate on the recreation, but hopefully just by looking at those 2 of those, you agree that the spirit is the same. The dashed lines are on the top ones are for projected values that they couldn't actually measure for a variety of reasons. So I omitted that. It's the spirit of the thing, right? So first question, right? Who is the audience, and what should they get from the figure? Anyone want to jump in? So.
Technical.
Yeah, right. It's been submitted to a technical conference, so the most likely people to be reading this paper are going to be other researchers in the field, right? Machine learning, in a machine learning field. The people making the decision, we go back to that, are essentially going to be, there's going to be sort of 2 decisions that are going to be made. The reviewers are going to be looking at it and deciding if they want to accept this paper to the conference and to be published. And practitioners like us are going to be deciding whether or not we want to try using these global filter networks instead of something else that we're doing, right? Like, do we want to put out the effort to use those? And then what are they trying to convey? So what's the...
Or just comparing the framework to others.
Yeah, so it's comparing, presumably lower is better, because there's the GF ones are always on the bottom, so presumably lower is better, right? And they have some other things. So a little background. So the other 2, I don't even know what they are, but I know they're transformer-based models, and so they're saying again their global filter stuff is better than transformers.
I think the one in the middle though is just straight up, fully connected. That is totally relevant. But
It could be, yeah. So, yeah, figure on the left, G-flops. It occurred to me when I was doing a dry run last night that people, if if they're not sort of in the field of, in the computing field, the GF and G flops might be read as GF flops, and that might be like global filter, right? Because that's the same like. Anyway, so that's like computational complexity or computational cost, basically, right? Lower is better latency, sort of how long it's taking to make a decision. Lower is better memory, whatever memory being used. Okay, so first thing we can do, right, to improve these, just remove some noise. So we already said sort of 6 steps on that, right? Removing backgrounds and borders, labeling stuff directly, and so if we do that, it looks something like this. So that's, argue, is that better or worse? Well, I'm willing to have that argument.
The lines help.
Yeah.
I mean, like taking them out helps.
Yeah.
I'm a little conflicted because I'm used to seeing the original because that's such a common practice. That's such a common template for these papers. So I'm better at reading those than I would say this because I've never seen this precise format before. So
you mean with the background grid lines is easier to read, or?
Yeah, because I'm used to staring at those.
Yeah.
So for me, it's deciding this is objectively better, I think, but then I'm not used to it. So it's
yeah.
So in my eyes, it's like kind of a wash.
Yeah. Yeah, that's a good point. So George brought up, hopefully it was audible on the line, but that, if you see something that's not like what you're used to, that adds some cognitive load to looking at the figure, and that is true. The other thing I'll mention, so the grid lines that we saw back over here, right? Those could be useful if the specific values on the line were important, right? Because it could make it easier to find specific values on the line. And part of the reason why I was okay with dropping them here was that I didn't really think the specifics of what those numbers were mattered that much, right? So the trend is kind of the more important thing, and the sort of the relative ranking was more important. The next step is like, how do we focus on the data, right? So a couple of things that I talk about in the book, right, is, or again, like when we talk about color, right, here we've colored like everything, right? And that sort of, like if you didn't know that this paper was the GFNet paper, like would you know which one was theirs or which one they're advocating for, right? So we really want to sort of focus on that. So basically, I'll just show you everything I did at once. And so, boom. Okay. So that's definitely different than you've probably seen in a research paper. I will grant you that.
One thing I've seen that, I don't know how I feel about this, maybe you can tell me what your opinion is. They just use hours as the label.
Yeah, so I'm mixed on that.
No, AOURS, like our proposal. Oh, our.
Yeah.
Which is, it's ambiguous, but it's also clear, like.
Yeah.
Yeah, I don't know. I have mixed feelings about that.
Yeah, so my opinion of using ours versus like theirs on a figure like this, I'd say maybe in a presentation that might be okay. I'd say in the paper, probably I personally wouldn't do that, just because, well, I want people to remember the name. So, and ours isn't as specific. And it sort of feels a little informal for research to me. So a few of the things that I've done here, if you sort of like go back and forth, right? So I've made it so that the only color that's there is on the hours part, right? The thing that I want people to focus on. I've made the labels on the axes gray so that they're not sort of popping out as much, but they're still there. So it's not like you can't read it, right? So we haven't lost information there. And I didn't bother to color the competitors differently because really it's sort of, again, it's like an ours and theirs. And so, I grouped all the theirs into one color. They're still labeled individually in case it matters how they're relatively ranked. But for our stuff, anyway, so that was what I did. Okay. So the next figure, so if you remember that page, was this one. Oh,
Question,
yep.
the last one. I think this one really makes it more clear that like lower is better. I've seen in like a lot of like CPU benchmark diagrams that they will say like lower is better or higher is better.
Yeah.
What do you suggest about listing that explicitly?
If you need to, then I would say do it. My personal preference would be to make it clear, like what, like, you know, if it's like cost, right? You just kind of know that cost, like lower is better. Or if you see like, oh, profit, like, okay, more profit is better, right? It's like,
One thing I've seen is when there's variability in those metrics, like sometimes it's higher better, sometimes
Yeah,
it's lower
that
better. They use an arrow on the axis that points in the better direction.
yeah,
And so that's really helpful for me when they're not the same alignment that way.
yeah, yeah. Yeah, I guess the principle that I would stick to is try to make it easy for the audience. And so if you think the arrow makes it easier, then that's good. If you can pick a different metric, like for like neural network training, say, right, you could convey accuracy or you could convey error, right? One of them, bigger will be better, one will be smaller will be better. And so if that's consistent with other things, right, you want to say, oh, here's my validation accuracy and my training error, then you're like, you know, it's kind of, anyway, so I would try to be consistent, try to pick things that make it as clear as possible. And if it's still not clear, then yeah, then you do what you need to make that clear.
This is if there's an interesting choice in this plot, and maybe specific to this area that I don't know about, which is the x-axis is not linear, it's quadratic.
Yeah.
And that like makes sense when you look at plots. They are also, I think they would be linear if that were not the case.
Yeah, that's a good question. I actually saw that in the paper too, and I was unclear to me why they conveyed it that way.
Yeah, there might be some reason to do it that way. I mean, it would be weird looking if it were linear.
Yeah.
Because it would be.
Travis, can you repeat what Abe is saying? What's weird about it?
Oh, sorry. So Abe noted that on the x-axis, like the units are all squared. So the axis is sort of like not linear, and that's sort of an unusual choice. And I was agreeing that it did sort of take me by surprise, and there's possibly a reason for why they did that. Like I'm not sure what the reason was. You know, maybe it made it fit better on the plot, or I'm not sure. This was actually one where I debated on taking off those number of tokens. Like, does it really matter? It's just like, it's more to the right. It's like, and the message is that yours is better, right? So I debated on that. I decided to leave them in just so that you'd sort of have an idea of the scale of the problems that they're sort of tackling there.
And if I
And
saw that with no X labels, I'd be a little bit
skeptical. Yeah.
I'd
Which
say
is
this kind of
why,
just looks like a qualitative diagram
yeah.
instead of quantitative.
Yeah. So, that was why I left it. Okay, so figure 3. We have this one. And so my first question to people is like, what is this figure telling you? Like when you look at this, like what is the message? Like what are you supposed to understand from this figure?
I think it's like you use less G-flops but get better accuracy, right?
Well, if you use more G-flop, more gigaflops gives you
Or
more
I mean, like for
accuracy.
GFnet, you can use like less G-flops and get better accuracy than the other
Oh,
two.
okay, yeah. You can use our model. It's less computationally expensive and better accuracy. Yeah, I agree.
I would take away from this, listen to what Travis just said about not cluttering up your figure.
Wait,
Yeah.
what did he say? I don't hear the joke.
So Abe said the takeaway is that you should listen to me and not clutter up your figure.
Yeah, I'm with you. There's a lot of text on this.
So this is sort of the downside of labeling the data directly, right? So like if you have a lot of data and you try to label it directly, then it gets messy in a hurry, and it makes it hard. It makes it hard to read any of the things, like if you wanted to read them. And there's just so much like overlapping stuff. It just really is kind of noisy. The other thing I was going to point out here is that this is really sort of, in my mind, what this is showing is as a trade-off, right? Like a trade-off between accuracy and gigaflop and computational cost. And so if you've done any like two variable optimization, you may have heard this term like Pareto front, right? But anyway, if you have that red line up there is sort of a Pareto front, right? And they're saying, hey, all of our points are on that front and the other ones are below it. So ours is like better all around is what's kind of going on. Okay, so making it better, right? So we can go through this step by step. Again, remove backgrounds and borders. We can, so I'm going through these sort of slowly because I was sort of experimenting myself with like, what do I want to do with this? So, getting rid of the background and border was easy. Then I'm like, those labels are just a mess. So maybe I can get rid of some of them, right? So I kept, at this point, I've like kept the labels for our stuff and taken off the ones for the other ones because I'm like, ours matters more than theirs. So, and again, I should just remind you, the exact numbers that are going into this plot are shared in a table in the paper. So if those exact numbers matter and the labels for which models are which matter, it's in the table in the paper, you can go and get it back up. So the point of this figure is not to convey exact numbers. Okay. So anyway, so remove some labels. Okay, and I'm looking at it. What else can we do? Well, can we remove lines, right? Like lines and scatter points. And so, okay, I actually did two things here. So I removed the lines from their stuff, kept the lines for, I'll say our stuff, even though it's not this is not my paper, right? But I'm still calling it our stuff. So I kept the line for that. And the reason was a conscious choice, again, because this is like the Pareto front for, two variable optimization. So I wanted to sort of emphasize that. It is maybe a stretch to assume that the accuracy sort of linearly increases between those. That's maybe a stretch, but I kept that one, got rid of the other ones. And then the other big thing, which I think was just an oversight on their part, was that in the first figure, their color for everything was blue. If you remember, we added the GF nets were blue, and that figure on the left, it became red. And so that was a bit jarring, especially since they reused the blue for something else, right? So I switched it back so that our stuff is still blue again to be consistent with the other figure. And then, okay.
Oh, sorry.
Sorry.
I was just going to say one thing. I think I kind of like to see like the comparison models just because like I think sometimes papers pick stuff that is like deliberately lower and I can kind of gauge like, I know there's this other model out here and like you haven't put it, which makes me think you're doing worse than it kind of a thing. Like, is there a way where you can like maintain like the types of models and still like show the data in like a less cluttered way?
Yeah, that's a good question. I think the answer is probably yes. So for example, instead of like grouping all the transformer stuff together into just those sort of like the gray scatter, we could have used different scatter markers and then kept a little bit of a label for like, oh, these were like the residual MLP or whatever those models are, the DEI transformer models, or we could have done that. And maybe instead of getting rid of all of the labels, maybe we wanted to keep like one example from each, like one label of like one example of a res MLP model. If there's a common one from literature, we could mark that on there. I think that would have been fine also. But again, like I said, like there is the table too. So like you can see all the names and numbers in the table. And in my mind, the sort of the point of this figure was to show you that like that front line and to show you that our stuff is on the boundary and the other people's is below it. So yeah, that's like design decision that you have to make. The other step, right, was sort of labeling data directly. which is sort of already done here, but we still have a legend. So, I was thinking, do we still need that legend? Or if we've labeled stuff directly, and can we focus on data? And so this is what did it change here? Oh, sorry, grayed out axes here to sort of defocus those. It also helps, like this label here was sort of overlapping the label there, which made it kind of hard to read. So graying it out sort of helped. But ultimately, I sort of went with something like this. Again, this is my design process. I'm not saying you should do what I do or what I did, and I'm not sure I would do this in every case, right? So lots of caveats, but this is sort of where I settled. So I've labeled directly. I used the whole word for the models this time, just to reemphasize the name from the thing in the paper. And anyone who wants to say that I shouldn't have taken off those labels, I'm willing to believe that you're maybe right. So, I sort of went back and forth with this. The point is that it's focused on the important bit, like that trade-off front, and we've highlighted very clearly the stuff that's ours, and hopefully it's clear that ours is better. The one thing, like in my mind, is like if I sort of take off the visualization hat and just go to like researcher hat, the real question I have is around these models here that are close, because I know like all these numbers that they're going to measure are going to be noisy, and what I didn't get from the paper, and so I couldn't incorporate it into the figure, is like how noisy are those numbers? So like, is that a statistically meaningful difference? My guess is that it's probably not statistically meaningful, but I don't know, right? So I didn't do that work, and they didn't convey any such numbers in the paper. Okay, so when we put it all together, right, we started with this, we ended with that. And if we look back at the page, right, so if I there's their page originally from the paper, if we replace it with our, I'll say improved figures, then we end up with something like this. And I think when you look at it as a whole, I think it's just nicer to look at the page on the right. I don't know.
I think the highlighting and color consistency is what really makes the difference here.
Yeah.
Because when I see that second page, everything that's bolded being the same color really tells me the picture right away.
Yeah.
Whereas this other side, I'm totally confused by what's wrong.
Yeah.
Yeah, I wouldn't think like coloring the text would make such a huge difference, but it's like it's way easier, like way faster to associate things. Like that makes a huge difference.
Yeah.
Well, and even in a setting like this, your improved diagram on the right, I can read it here in a big conference room. While I can, it is difficult to read the little texts that they have up there on the left side.
Yeah.
So good for presentation.
Yeah. And so speaking of presentation, right? So if work like this gets accepted to a conference, one of the things that you'll be expected to do is to go to the conference and present the work, right? So then I'll say that I am guilty of doing this. When I go to present stuff, pulling figures directly out of my paper and pasting them into a slide, right? I'm sure I'm not the only one who's done that. But I don't know that that's the best idea, and I wouldn't advocate for that. So like when you're presenting, it's a different audience with different needs, right? Like they don't need specific numbers off of things in the slide. When you're giving a presentation, you have a different goal, right? So when you submit a paper, your goal is to get the reviewers to accept it, and then to accept the paper, and then when people are reading it, you want them to use your thing, right? When you're giving a presentation, the goal is really to convince people that they want to read your paper. So it's sort of a different goal. So you don't want to use the same figures when you have a different goal, right? So with that in mind, here was one more iteration that I did on the figure, which I would not put into a paper. So don't like skewer me for saying you're asking us to do what. But so an even simpler version, right? So I've replaced G-flops with computational cost. So I think that makes more sense to more people. And the precise numbers on that axis really don't matter. and accuracy. So you did lose like accuracy on what. So maybe I want to say like ImageNet accuracy or something. I don't know, right? But anyway, wouldn't put that into a paper, but at a presentation, something like that, or especially if you're talking to a general audience who's not all researchers in machine learning, a figure like that would be more appropriate, right? So all that is to say, the audience matters. Your goal that you have matters. Okay, next paper. How are we doing on time? We're about done, aren't we? Wait, we've been to a.
I think we've got till, I think you got another.
Oh man. Okay, so 11 minutes. I'll fly through this one. So this one, paper is that, the claim is that if you augment your data in the right way, then it can improve robustness. In this case, robustness means it's better against adversarial attack. Again, published in NeurIPS. So let me just show you a couple of figures. So here's a couple of figures from the paper. Maybe I'll just answer some questions for you instead of asking. So figures do well. So I like that they've removed a lot of the noise, right? There's no background filled in. They have a couple of grid lines, but those look like to me they're chosen specifically, which is good, right? Those were intentional choices. One thing I didn't notice from the paper to when I was looking at it in the paper, I didn't realize that the two figures weren't the same size. But when I cropped the paper and stuck it in here, all of a sudden I realized that the figures are subtly different in size, which has a couple of impacts. One, it makes the font sizes different, which is annoying. Two, it makes the lines not line up, which is kind of annoying too, right? The other thing they've done is they've colored everything, which is maybe okay. And this one is one where they have the legend, but you really can't label directly on that data because again, it's so close together, you really just can't do that. The question in my mind is like, are they advocating for one of these over the other? And they're not. So, but the real sort of downside of these figures is when you see them, you think, oh, what you're doing is you're sort of ranking these different algorithms, right? And you have sort of the one on top is better and the ones on the bottom are worse. That's sort of the message that I got initially. But when you read the paper, what you realize is that what they're actually talking about is this blue one slopes down and the orange one slopes down. So those are bad. And the ones that are flat over here are good. Right? So what they're saying, they're talking about this overfitting, right? So if your accuracy starts going down, then you're overfitting. So they're saying, hey, if you're using these two kinds of data augmentation, you're going to be overfitting. And if you use these other ones, you're not. Right? So in my mind, the only thing that's really kind of bad about these figures is they don't convey the message that they want to convey, which is, these two are overfitting and these ones aren't, like when you look at them. And I'm not going to iterate on those figures, but let me look at just one more. So here's two more figures. Again, good things about these. Again, pretty clean. This one has grid lines again, which I don't think you need. These numbers, again, are all in the paper in a table. The problem here is they haven't been consistent with colors from this figure to the previous one, even though they're using the same methods. Or a couple of the figure colors are the same, a couple of them aren't. They've added new methods that they didn't show over here, which was surprising to me. And then the same four colors over here, the thing that's weird about it is all of those colors are variations of the green one right here, which is confusing, right? So anyway, I didn't iterate on all these. If this were me, I would probably make these all shades of green so that they match up with that one. And so I iterated on this figure a little bit. And the thing that I iterated on was really like, is a scatter plot even what we want here? And with this, the whole paper is about robust accuracy. So accuracy against adversarially perturbed data, which is this y-axis. There's like, the paper isn't about this. So like, why are we showing that? And so long story short, what I tried first was to turn that into a bar chart. Okay. So, the other thing is that the message here is that sometimes they're basically they're making an argument about why this weight averaging is better, and in what cases it's better. And that didn't really come across to me here. So I'm like, well, if I put it this way, at least now it's clear that you're getting higher accuracy when you're weight averaging. Right? In all these cases, it's higher. I debated on whether or not to include the clean test accuracy, the stuff over here on the right, at all. And the other thing, I guess Tracy asked earlier about labeling directly data. Like here, I've done it, like with the bars, like it's labeled directly. Those colors don't match. Anyway, I ended up thinking, this figure is really still just trying to convey all of the data, which wasn't what I wanted. So the point again of this figure was that in which cases is the weight averaging better?
I don't know if I agree. So this one is, I would worry that just like seeing this figure, not knowing what this figure was about, I would worry that you might think, oh, it's good to have the solid part be a larger fraction of the light part, rather than you want the solid part to be higher and the light part to be higher. Both of them are good.
Yeah, and that's part of the reason why I kind of didn't want to have the light part at all, because it kind of seems confusing to me.
I agree with that.
So what I ultimately decided was that the bigger thing, and from reading the paper, is this difference here is really what matters. So what I did is I reduced all these to just the differences, and we get something like this, right? And so it happens to be that these two methods were the ones that overfit. And so what they're saying is that basically these pre-processing things, the weight averaging helps when you're not overfit, which is the blue category, and it doesn't really help when you're down here. Anyway, so that's another iteration on this. We're just about out of time, so I want to make sure there's time for questions. These slides will be available even to people externally if you want to look at them. I'll just say, okay, the big points, right? Target your decision makers, design with the interpretation in mind, eliminate clutter, focus on data. Here's the references. The first one is the book that basically got used for everything, just about everything in this talk. There's some others there that I have the papers referenced. And I'll mention the lowercase storytelling with data is not a mistake. I think the author has an issue with uppercase letters. So I don't know if there's any uppercase letters in that book. So that was the only thing I didn't like about that book, to be honest, was she doesn't even capitalize her own name when in the book. So anyway, sorry, man. Anyway, if you'd like to continue a conversation with me or whatever, ask questions, I have contact information here. Again, these slides will be available and up and available. Do we have any questions? There are a few people on the line I know asked some questions. Is anybody else? Oh,
yeah,
go
thanks for the presentation. That was really nice. First time I've ever heard of the Gestalt principles.
Yep.
Can you maybe speak a little bit more to those and other principles that you might have come across?
Yes. So can we talk offline?
Sure.
So there's a number of principles, things like closure. See you, Katie. I can show you some offline. The book has a whole chapter about them. So there's kind of a lot.
Okay. Yeah, they seem pretty interesting, pretty useful.
Yeah. Any other questions?
I think Katie has a question.
Okay. Oh, was she? Oh, you're raising a hand. Sorry.
Yeah.
Goodbye.
Yeah, well, I'm also gonna have to sign off, but I wanted to ask you specifically about accessibility, because one thing that struck me in like emphasis versus colors to distinguish between them is that that's more accessible to people who might be colorblind or anything like that. So do you have any comments on making figures more accessible to a broader audience?
Yes, and you should definitely do it. That's so as far as colorblind goes, it's like 8% of men and 0.5% of women can't distinguish like red from green. So with some of those figures that we saw in the last, where they had like the four plots, they had red and green right next to each other. Anytime you kind of see that in a figure, that should sort of be a little alarm for you. But it's good to sort of make things different in multiple ways so that it's easier for people to distinguish. So for example, when we were like bolding those lines, like bolding some and making the color and not using multiple colors, that would help a lot, just because of the intensity, like you could tell the difference there. So that's a good reason not to overuse color, because the more colors you put on the page, the harder it gets to make them colorblind safe. And there's also, if you do want to have multiple colors on a page, there's a good website. It's called a Color Brewer, 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 Color Brewer. And they'll let you sort of experiment with palettes. You can sort of put some constraints on there for like, if you want to be photocopy safe or colorblind safe or whatever, and come up with some good color palettes. Don't use default color palettes because they're almost always bad. Yeah. There's a lot. There's an entire chapter in the book devoted to making figures accessible, and you should definitely do it. So, thanks, Katie. Good to see you. All right. Any other questions? We've got about a minute. Oh, I can't hear you, Greg. Sorry, I saw you unmuted. If you want to post up a question, you can type it. I think.
Looks like Greg is typing, so we'll just wait. Oh, there we go.
Yeah. Okay. Yeah. So while he's writing that question, just a reminder: the slides will be made available. I believe we were recording this, so the recording should be made available. That will be online. You can feel free to share. And again, my contact information is in there, so if you want to reach out to me directly about anything, feel free. So.
Thank you so much, Travis. Excellent presentation. Oh, Greg's question.
How do you balance seeing the real trend of the data versus wanting to convey the trend line, thinking of that noisy data versus the smooth versions? So do you mean like if you sort of have a best fit line? Okay, I see. Would you add error bars? I would say if you have the data to do it, then yes. And there's sort of a few strategies that you could try. So one would be sort of having a trend line in bold and then like a lightly shaded background that sort of gives you like a width around that line. That's sort of a clean way to do that. You could put like the box and whisker plots. Personally, I'm not a fan of those. They are pretty common in the sciences though. I would just be careful about how much information you're putting into those box and whiskers. And like, are you drawing attention to the whisker? Are you trying to put like mean and median and like 95th and 5th percentile? Like the more you try to put in there, the harder it becomes to focus on that. So you just have to be really cautious about and deliberate about what do you want people to be focusing on, right? If your argument was, this method is statistically better than that method, then those error bars are going to be very, very important. So they're going to be something about the distribution.
Can you hear my audio now?
Yep.
Okay. Yeah, so what brought that up was the last example you had where they had the smooth version, you could see the trend much better, but sometimes, at least for the technical machine learning side, we're interested in also the variance. Like I was training a model recently, and in TensorBoard, when you're varying results, TensorBoard is a great GUI, just like MLflow, and you can see performance across epochs. And it automatically applies a smoothing. And so when you look at your loss across epochs, it smooths it to like a factor of like 0.6 on a scale between 1 to 0. So if you turn the smoothing off, sometimes it's extremely noisy and you don't see trends, but sometimes you can see there's information in that noisiness that we can pick up on that's useful from a research perspective. So it's always a trade-off for me, which is why maybe adding error bars or something like that would be helpful, or at least say like these lines had this variance associated with it, while these other ones were much more deterministic and followed the trend much more consistently.
Yeah, and that's one of the cases like when you're actually analyzing the data, like and you're in the process of like you're training the model right now, I think seeing more is better. That's again one of those cases where you probably want to see everything and be able to play with it all. Sure. But then once you're done and you're going to like convey something, then it's like, what is the thing that I want to convey? Is it that do I want to sort of convey like, yeah. So you just have to be deliberate in what it is that you want to convey. But yeah, when you're doing your own analysis, I think pretty much there, more information is almost always better to be able to play with and to understand. And
yes, I agree with you there.
I do think that like you should be very careful because like once you start summarizing data and throwing it out like that, like you have an angle. So
Yeah.
You should be very clear about what your angle is.
Yeah. Anytime you're removing data, you have to be careful because there's lots of pitfalls that you can fall into. Yeah.
Also, I think I was actually talking with Mike Burden about this yesterday. That annoys me. That's a word. They shouldn't do that.
Cool. I appreciate everyone joining. I think we're going to have to call it there. We will likely do some more externally open journal clubs in the future, and we'll be sure to advertise those. So,
Thank you, Travis.
thanks.
Thank you.